Okay, Assalamualaikum and good afternoon. Okay, so I think we can start the class. You can hear me, right? Can you hear my voice?
Can.
Okay. Okay, so before we start the class, I would like to remind that next week is our task. Okay, so again, it is only one task for this course. Okay, before this we have two tasks. So most of students, if they cannot score the test one, they will recover in test two. But in your case, we have one test only. So by hook by crook, you have to score on that test lah, because that test it is about half of our carry mark. So 30% of your carry mark. So half of your carry mark. So please make sure that you are well prepared for the test and perform on that test. Okay. So our test will be on Thursday next week, 26th November. Okay. So the test will be at night, 8:30 p.m. until 10:30 p.m. So you have about 2 hours for your task. Okay, because of 30%, so it is about 2 hours. Okay, so 30%, the total mark is 60. Okay, 60, the total mark is 60, 60, which is 30% of your coursework. Okay. So as in teaching plan, okay, the material is from 1.1 until 3.2. Sekejap Okay, sorry. The material is from 1.1 until this week material. Okay, so 3.1, just a two subtopic of chapter 3. No? Okay. Okay. And then next week, I'm planning for cancel all the class. Okay, because Wednesday actually I got something to do, family matter, my personal thing lah. Okay, so Wednesday, I don't think that we can have a virtual class on Wednesday, and Monday, I will inform later on Monday. But if we have class, maybe we just discuss a few things regarding the test lah. Okay, and then the subtopic for the next week, I will bring to the next 2 week lah. So maybe the next 2 week we will have virtual class on Monday and also on Wednesday to cover the subtopic for next week. Okay, in case that we don't have class next week. But so far I cannot do class on Wednesday lah. So on Monday I will inform later whether we have class or not. Okay. But if you have class, I just want to discuss a few things about the test, or maybe you can ask me any question regarding the task. Okay, so preparation for the test, of course, you have to do all the exercise that we have. Try to redo the exercise, and then the tutorial question, you can try the tutorial question. Okay, do not just depends on the exercise question. Okay, because I always say that because tutorial question, you already know this question belong to which subtopic, so there is no challenge. Okay, it's not challenging lah. Okay, because you already know this question from which subtopic, so you already know what parameter that you have to estimate. You already know which formula that you should focus. Okay, so this is not there's no challenge on that. Okay, so that's why at least you try the tutorial question, because tutorial question is a mix of the subtopic. So you have to know by your own, okay, this question from which subtopic. So what formula that I should focus, what parameter that I want to estimate here. Okay, So after that, you can try the past past semester, the test from the past semester, okay, previous semester that you can find in Kalam. So I think we have a few set of the tasks from previous semesters. Okay, so you should try lah. Okay, that one. And it is important to train yourself to solve all those questions within 2 hours. Okay. Usually for the test we have about 6 to 7 questions. Okay, but I think if you refer to semester 1 2019 2020, the total mark still about 75 like that lah. So previous semester we what we call, we reduce the total mark to the 60, so means that the number of questions should be reduced lah. Okay. That's the preparation for the task. Okay, so make sure to train yourself to solve all those questions within 2 hours. Okay, because it is similar when we go to the final. You have to train yourself, okay, to solve all those questions within the given time without refer to the module, okay, without refer to any source. Okay, and then you have to plan. Okay, you have to make your own plan. Which question that you need to answer first and so on. Okay, that's a, I think also important, other than you study. Of course, you have to study, but also you have to train yourself, okay, to answer those questions within 2 hours. Okay. Okay, so today we proceed to the subtopic for this week. So you should study from 2.5 until 3.2. Okay, so we go to the 2.5 confidence interval for difference between two population proportion. Okay, so estimate the confidence interval for the difference between two population proportions. Okay, so when we have proportion, okay, then it will be easy. Okay, other than population mean, the rest should be easy. Okay, why? Because you have single formula only. Okay, I think the population mean, the difficulties on to choose the formula. Okay, which formula that we need to use. Okay, but after that, when you have proportion, when you have variance, it will be easy because we have single formula only, okay, to estimate those parameter. But before that, you have to know lah what parameter that we need to estimate, what confidence interval that we need to construct, okay, for the proportion, or maybe for the variance, or maybe for the standard deviation. Okay, after that it will be easy because you have single formula only. Okay, but for the population mean, okay, as we know, we have different formulas, so you have to know what condition that we have, and then we need to choose which formula for that condition that we have in that question. Okay, so I don't think that we need to discuss the formula because it's just a simple formula here. Okay, so because of we have two population proportion, that's why we have pi1 minus pi2. So similar when we have mu1 minus mu2, okay, it is based on the question which one minus which one. Okay, so estimator for the pi, we have p1 and p2 here. Okay, so depends on the question, it could be p2 the question. Okay, and then we use the Z distribution in this case, and then the whole thing here, that's a standard deviation for the pi1 minus pi2. Okay, so the second term here, similar as before, that's your estimation error, the E, estimation error, or margin of error. Okay, another name for the estimation error, we have margin of error. So similar thing. Okay. Okay, so you have the what we call example here. Okay, even though the pi here, it must be from 0 to the 1 only, but when we discuss the different, it could be negative confidence interval. Okay, sometimes we get negative confidence interval because here we calculate for the different. So if your P1 greater than P2, then you could get negative confidence interval lah. Okay, so similar, if the value here greater than the value here, then for the lower bound you could get negative confidence interval. It is okay to have negative because we calculate for the different. Okay, so that's why the interpretation will be different because we need to make sure the confidence interval that we have is a significant one lah. Okay, that's how we counter back. Okay, so last week we already discussed when we have negative confidence interval what to do lah. Okay, and I think that I forget to mention in our class last week, when we have proportion, okay, when we have confidence interval for the proportion, when we interpret, we have to convert into percentage, okay, because proportion, it will be what we call more significant if we use the percentage. Okay, I think I forgot to mention that in our class. Okay, so when we have the proportion, okay, in the interpretation, we have to convert into percentage. Okay, you can interrupt me anytime if you have any question. Okay, because I feel like DJ here. Okay, so we have the lower bound and upper bound, the what we call the idea similar as a single population proportion. Okay, so it is between 0 to the 1 only. Okay, when we calculate for the lower bound, okay, the A automatically upper bound equal to 1, which is 100% lah if we convert into percentage. Okay, when we calculate for the upper bound here, we calculate for the B only. So here there is no problem with the formula. We have that formula only, single formula only. The only thing that we modify is our alpha. Okay, when we calculate for the one-sided, it's just alpha. Okay, no need to divide by 2. Okay, so when we calculate for the upper bound, we calculate for the B only, automatically lower bound here equal to 0 because the minimum value is 0, the largest value is 1. Okay. So we go to the number 2. Okay, I ask you to do the number 2. Okay, I think number 1 should be discussed in video. So we go to the number 2. What is the variable here? What is the variable? Okay, so we have two different things here. We have what? Gold wire, and also another one is a aluminium. Okay, so we have gold, we have the aluminium. What is the variable? Anyone?
Specification match.
What? Wire that match specification. Okay. Wire okay, so wire that match spec. Okay, so that's your variable. Okay, in a sample of 85 unit made with the gold, 68 unit met the spec. What is 85 here?
Gold.
It is? Huh? 85?
Sample for gold wire.
Sample for the gold. Notation?
N.
Okay. So 68 unit met the spec. So 68 here? 68 here?
Aluminium. Aluminium. N.
X1.
It is X, number of success. Okay, for the goal. Okay, we have from 85 unit, 68 met the spec. So 68 is your success, number of success. So that's your X for the goal. Okay, and then Y in the sample of 120, 120 is your N for the
Aluminium wire.
aluminium. And then 105 unit met the spec. So 105
X.
X.
Aluminium wire.
aluminium wire. Okay, so for the variable here, it also correct if you write wire that do not match spec. Also correct because also the data that we collect lah, okay, also correct. So find the 95% confidence interval for the difference between population proportion. So it is clear that you have to find the confidence interval for the population proportion for the circuit made by aluminium and gold wire. Okay, so aluminium and gold wire, automatically you have to do P aluminium minus P gold. Okay, so means that aluminium is the first population and gold is the second population. Okay, so how do we identify which one is the first and second based on the question here? Okay, when we need to find the confidence interval of what, between what and what, that's how. From that we identify which one is the first population. Okay, so kalau in test letter you buat, let's say that you buat gold minus aluminium, also accepted, tapi 1 mark will be deduct. Okay, because you didn't follow the question. Okay, so still accepted, I will still mark your answer until the end. Okay, you will get full mark, but after that 1 mark will be deduct. Okay, because you didn't follow the question. Okay, that's the what we call the effect lah if you didn't follow the question. Okay, so aluminium and gold that not met the spec. Okay, that not met the spec. Give comment on the parameter estimate. So how do we comment similar? Okay, if you have positive, if you have negative, how do we comment similar as what we did before? Okay. Okay, we go to the solution. Okay, so we need aluminium and gold that not met the spec. What does it mean, not met the spec? So now, okay, kita nak construct confidence interval untuk success characteristic ke ataupun kita nak construct this confidence interval for the failure characteristic? For failure characteristic, because you are given success characteristic which is met the spec, but the confidence interval we have to construct the confidence interval based on the wire that not met the spec. So means that we construct the confidence interval for the failure characteristic. Okay, so that's how we twist the question for the proportion. Okay, we give you success characteristic and then we ask you the opposite one. Or maybe in that question, we give you the failure one, but we need you to construct the confidence interval for the success one. So that's how we twist. Okay, so whenever you have the proportion question, be extra careful. Do not jump to the solution. Read the question carefully, what you need to construct. Okay. So we need for the failure, so it is between aluminium and gold. So Q aluminium minus Q gold. Okay, confidence level is 98%. Okay, so pi aluminium minus pi gold. Okay, in case that you want to modify your formula lah. But you can always follow the formula that we have here. Okay, but you have to know that the P here, your Q. Okay, so to be easy, or what we call, so that you are not, you notice that we need to calculate for the failure. So it'll be easy if we write our formula in this form lah. Okay, so we need QA and then QG, but here we are given arts. Okay, so we have aluminium, we have gold here, we have the N, we have the arts. Okay, 85, 120, 68, 105. Is it correct? Okay. Okay, so from here you can calculate first the P, and then what is Q? How to get Q? How to get the Q? How to get the Q?
N minus X.
What? How to get the Q? N minus X, you get the failure case, you get the number of failure and then divide by N. Okay, so you get the Q. Or it is 1 minus P. Okay, you calculate first the P and then 1 minus P, you get failure. Okay, or it is 85 minus 68 and then divide by 85, then also you will get Q. Okay, you have done, right? Okay, what lower bound you get? Lower bound?
0.2.
0.2 only. Negative. Your friend got negative? Upper bound? Okay, upper bound?
0.1980.
1981. 80 also okay, 81 also okay, and then interpret. So it is okay to have negative confidence interval because we calculate for the different. Okay, so when we interpret, so we are the what? The difference between the difference between population proportion. Okay, basically you can copy this sentence. Okay, convert into percentage, so we have 4.81% more by gold wire and 1981. Tambah kat sini sikit. That not met spec. This is important, that not met spec. Percent more by aluminium compared to each other. Respectively. Okay, so quite a bit long, okay, because of we have negative confidence interval. If you have positive, then it just simple like we do before, okay. Any question? Okay, so we proceed to the next one. Okay, confidence interval for population variance and population standard deviation. Okay, estimate the confidence interval for a population variance and standard deviation. It will be stated in that question whether you need to construct confidence interval for variance or standard deviation. Okay, but it's just one formula. Okay, so confidence interval for the sigma square and then confidence interval for the sigma. Similar formula, but for the sigma we just square the value of confidence interval for the sigma square. Okay, so for the sigma here we use chi-square distribution as our distribution. Okay, we use chi-square distribution as our distribution. Okay, so so we have the lower bound, the upper bound of the chi-square here, and then lower bound of the chi-square here. Okay, should I show how to get that value? Oh, you already know? I think it has been discussed in video. Okay, so for the chi-square, the critical value you can refer on table 6. Okay, chi-square distribution, table 6 in your statistical table. So we have two pages, 38 and also 39. Okay, so we go to the example. Okay, so for the one-sided, okay, so the sigma here, the sigma square or sigma, it is between 0 to the infinity. Okay, so for the variance, we cannot have negative variance. Okay, so it is from 0 to the infinity. Okay, so if you calculate for the lower bound, so means that alpha for the chi-square distribution, no need to divide by 2. We just calculate for the A, automatically upper bound equal to infinity. Okay, so if we calculate for the one-sided upper bound, okay, we calculate for the B, automatically lower bound equal to 0 because it is from 0 to the infinity. Okay, okay, let's do number 2 here. Okay, you already done this one. Let's modify this question. Find the not in our statistical table. 98%. Okay, tak ada statistical table, so we change to 95%. Okay, for the critical value, so far kita memang tak bagi soalan yang for the assessment. Okay, all the critical value should be in your statistical table, exist in your statistical table. Okay, no need to interpolate or something else. Okay, it will be in your statistical table. Okay. Okay, so find the one-sided upper bound of 95% confidence interval for the population variance of dissolution rate. Okay, interpret your answer. What is variable here? Variable?
Dissolution rate of some chemicals.
Dissolution rate of chemical. Okay, so we need to construct the one-sided upper bound. Okay, So 10 independent measurement of the dissolution rate of a certain chemical are taken. Okay, so we have only 10 data, okay, of the dissolution rate of the certain chemical. It is not from all. So this is sample data. Okay, so find the one-sided upper bound of 95% confidence interval for population variance of dissolution rate. So interpret your answer. Okay, so we need CI of the population variance. Okay, so the upper bound. So upper bound automatically lower bound equal to lower bound equal to we calculate for the
Zero.
upper bound, automatically lower bound equal to 0.
0.
Okay, we calculate for the upper bound. Okay. Sekejap, saya tulis kat sini. So we need one-sided sigma square. Okay, so automatically lower bound equal to 0. So to find the upper bound, so chi square 1 minus alpha, no need to divide by 2, just alpha and then the nu. Okay, so nu here and minus 1. Okay, so we need to find s square from the data and then we need to find the critical value 1 minus alpha. So alpha 0.05 minus 1 0.95. Isn't it? Good. Okay. The nu 9. So we need chi square 0.95 and 9. In your statistical table, we have
3.3251.
3.3251. So everybody should know how to find that value. So 3.3251. Okay. So S square, what do you get from the data?
1.5909.
Again, I cannot hear you clearly. What?
1.5909.
Already S square or S? Okay.
S square.
S square, 0.9. Okay, so just substitute here. And minus 1 is a 9. So what do you get? Four point 3061. And then for the interpretation, okay, Do we have unit here? Temperature. Should we put unit here?
No.
No. Why?
Variance.
Variance.
Has no unit.
Because variance is a dimensionless, so there is no unit. Okay. Any questions so far? Okay. So confidence interval for the ratio of two population variance. Okay. So estimate the confidence interval for the ratio of two population variances. Okay. So we have, so one of the reason why we calculate ratio here because the variance cannot be negative value. Okay, that's why we avoid the difference. Okay, the variance cannot be negative value. Okay, that's why we have ratio. Okay, so sigma 1 square divided by sigma 2 square. Okay. So just a simple formula, s1 square divided by s2 square. So which one divide by which one depends on the question. So similar as we calculate for the difference. Okay, which one minus which one depends on question. So similar to here. Okay. So for the ratio of population variance, we use F distribution. Okay, F distribution as our distribution. Okay. So for the F distribution, okay. Okay, so we have this formula. One minus. Upper bound. Okay. So for the F distribution, we have what we call three value. Okay, three value in a package of F distribution. You have the probability value. Okay, this is a probability value. Okay, you have first degree of freedom. Okay, so first degree of freedom. So before this, for the chi-square and also t, we have single degree of freedom. But for the F, we have 2 degree of freedom. So the new 2 here, is a first degree of freedom. Which one comes first? That's the first degree of freedom. Doesn't matter you have no 2 as a first. Okay, because you have, when we read from the table, okay, we read the new 2 here as a first degree of freedom. Okay, because in table we have different notation here. Okay, so in table, okay, so for the F distribution, it is in table 7, starting from page 40 onward until the end. Okay, so in table we have no 1 as a first degree of freedom and no 2 as a second degree of freedom. Okay, so regardless what notation that we have here, the first degree of freedom here we read from no 1 in table, and the second degree of freedom here we read from no 2 in table, because the first one first degree of freedom, the second one second degree of freedom. Okay, so no 1 here is a second degree of freedom. Okay, degree of freedom. So no 2 is a n2 minus 1, no 1 as a n1 minus 1. Okay, so our statistical table we have limitation on probability value. Okay, kalau if you use any software, then that's another story lah. Okay, but now we have statistical table, we refer on our statistical table. Okay, so statistical table we have limitation on probability value. So it starts from alpha 0.001 until you have 0.05 only. So there is no like chi-square we have, because when we do 1 minus here, it will be 0.95, 0.975 like this chi-square. But okay, that value does not exist in our statistical table. Okay, that's why for the lower bound here, the critical value here we need to improvise, we use another formula. Okay, so 1 minus alpha over 2, it will be 1 over, okay, f alpha over 2, because we need 1 minus alpha over 2, so we find in our statistical table alpha over 2, and then the position of blue 2 and nu 1 will be interchanged. It will be nu 1 first and then nu 2. So this is what we read from the table, and then 1 divide by the value that we get, and then we get the critical value for the lower bound. Okay, because 1 minus alpha over 2 is not in our table. That's why we use this formula. Okay, but for the upper bound here, alpha over 2, it is in the table lah. Okay, exists in our table. Any question on that? Okay, the formula that you have in table, okay, if you go to the page, what page? 7, okay. If you go to the page 7, you have the confidence interval for the sigma 1 square divided by sigma 2 square. And then the second row after that, you have this. Okay, so what you have in this table, statistical table, this is a general formula. So we have to modify this based on what we need. Okay, we need to modify this formula based on what we need. So what we need, 1 minus alpha over 2. That's why we have alpha over 2 here. And then we need nu 2, nu 1. That's why we have nu 1, nu 2. So do not follow this one directly. Okay, we have to modify based on what we need in original formula. Okay, any questions so far? Okay. Okay, so if we go, so I already sent to you the correction of the video for this subtopic. Okay. Okay, the crucial part here is on your critical value. Okay, sometimes you misread the value from the table. Okay, only that lah. Okay, but like this, okay, so the one-sided confidence interval here, the idea similar as a single sigma, okay, because it must be from 0 to the infinity only. Okay, so the idea is similar. Okay. Okay, the exercise 2.7 number 2 here. Okay, it should be easy. Why? Because number of n similar. Okay, you have n1 equal to 8 and n2 equal to 8. So you will get nu 1 equal to 7 and nu 2 equal to 7. So should be there's no problem because we have similar degree of freedom. Doesn't matter how you read the table, you will get similar answer. Okay. Okay, let's say that we have different. Let's try. Let's say that we have 95% CI, and then we have N1 12, and then we have N2 10. Okay, so for the upper bound, we need F alpha over 2, nu 2, nu 1. This is upper bound. Okay, so lower bound, we need 1 divided by F alpha over 2, nu 1, nu 2. Okay, so we just practice how to get this value. So F 0.05. Okay, nu 2 is? Nu 2 is? Anyone? The nu 2 here is?
9.
9. The nu 1? 11. Okay.
11.
Okay, but in this case, we have F 0.05. Okay, our nu 1 is 11 and nu 2 is 9. Okay, let's find the value in our statistical table. So what page or which page that we need to refer, it depends on the alpha. So find in what page that we have alpha 0.01. Okay, so refer to the first row in that page.
Last page.
Okay, so we refer the alpha based on the first row on your page lah. Okay, so what page that we need to refer based on the alpha. So we need alpha 0.05. So it is on page 54 and 55. Jumpa? Got it? Okay. So first degree of freedom, we read from no one. Okay, first degree of freedom, we read from no one, your row. Second row after the alpha. Second degree of freedom, we read from no two, the first column. Okay, so the notation here do not follow even though it is same notation, but do not follow the notation that we have in our formula here. Okay, even though here is a no two, we don't read from the no two here because no two here is a second degree. Which one comes first? That's a first degree. So we read from no one. Okay, so the first one we have 9, 11. What we have? The value that we have?
Doktor, 0.05 tu bukan bahagi dua ke?
Forget. Betul-betul. Okay, thank you. So bagi dua ada should be ada. So 0.025. Thank you. Okay, so it should be in page 44 and 45. Okay, thank you. 0.025 and here also 0.025. Okay. So what we have? We have? Anyone? $3.5879. The second one, we need 11.9. We have 3.9121. So divide 1 divide by that, then you get the critical value. Any questions so far? Okay. So in this question, okay, so construct a 96% confidence interval for the ratio of two population variances. So it will be mentioned in that question, okay, that you need to construct the ratio of two population variances. Okay, so it is clear that ratio of two population variances for all the roving coefficient, okay, produced by control and heat strength. Okay, so interpret your answer. What is the variable here? Variable?
Roving cohesion produced by control and heat strength.
Roving coefficient. This one. This is your variable. So we should do which one divide by which one? Based on this question?
Control divide by heat is strength.
Control divide by heat, because you already mentioned here control and heat. Okay, let's say that we have different quotient for all the Robin quotient produced by both strength. Okay, for example, both strength. So it's up to you. You can do control divide by heat or heat divide by control. Both will be accepted. But in this case, we need control divide by heat. So S control square divided by S heat square. Okay, multiply with the 1 over F alpha over 2, nu 1, nu 2. Okay, and upper bound SC square divided by SH square. 4 over 2, nu 2, nu 1. Okay, so here we have 96%. Okay, so alpha 0.04 divided by 2, 0.02. So in this case, we are lucky because number of n similar. So nu 7, 7. Okay, we should get lower bound. Lower bound 0.1274, upper bound 376. Okay, so all of you should get similar lah. 3.7645 also accepted. Any questions so far? Then okay, so that's all chapter 2. That's all chapter 2. Okay, so you should preparing for your task. Okay, how we call? Anything you can just ask me lah. Okay. If there is no question, we go to the chapter 3. You okay? Okay, so we have the hypothesis testing. Okay, another method for the inferential statistic. Okay, so what we do in confidence interval, we provide a range of value and then we estimate and we assume that okay, the population value lies within that range. Okay, so in general, for the confidence interval, we estimate the value of population. Okay. So hypothesis testing, what we do is we try to conclude something about the population based on the sample data. Okay, or we do the inference about the characteristic of the population based on the sample data that we have. Okay, for example that you create a new oil. Okay, fuel oil, for example. Okay, so you need to test, okay, that fuel is effective or not than the old one. Okay, So it will be impossible to test on all car that we have or all transportation that we have. So what we do, we just test on sample. Okay, we draw a sample. Maybe we test for about 100 car. Okay, and then we use a new fuel on that car, and then let's say that that car can drive until what kilometer. Okay, after that that car we use a old oil, and then that car can drive until how many kilometer, and then you compare lah. Okay, so what we do here, you have the data of the new kilometer drive, okay, using the new fuel, and then kilometer drive using the old fuel. Okay, so based on that data, we form the, or we construct the hypothesis testing. Okay, so we assume that our hypothesis, we assume that our new oil should be more effective than the old one. Okay, so we assume that new oil is more effective. So it is about kilometer drive. So if effective, the kilometer should be what? Higher or lower? If that oil effective, okay, so the kilometer or the distance drive by the car should be greater or should be less?
Greater.
Greater, should be greater. So then we have that sign. So the new oil should be better than the old oil. So we have this. Okay, so why we have greater sign here? Because the data that we have is a distance drive by the car. Okay, so if the oil effective, then the distance should be larger or should be greater. Okay, that's why we have new oil greater than old oil. So this is the hypothesis that we have. So by using the sample data, we construct or we calculate for the test statistic, and then we have the critical value, and then we compare. At the end, we make our conclusion whether it is really new oil better than old oil or not. Okay, and then after that you can do lah. If you are manager, then you can if it is confirmed that the new oil better than the old oil, maybe we can invest on that lah. Okay, we can invest on the new oil. If let's say that based on the data that you have, you conclude that the new oil worse than old oil. So what we do, we stop the production of the new oil. So we just remain to the old oil. Okay, that's the purpose why we do the hypothesis testing. Okay, we try to conclude something about the population. Okay, because it will be impossible to test the oil here to the old car that we have. Okay, it is impossible. So what we do, we draw a sample, maybe 100 car, depends. Okay, depends on the cost, depends on the time that we have. Okay, the number of sample, as what we discussed in chapter 1, it depends on the cost, it depends on the time that we have, the number of sample that we should have. Okay, so it depends. Okay, and then we make our conclusion which one is better than the plan after that lah. Okay, that's the purpose of hypothesis testing. Okay, so similar, your assignment part 2, it is about hypothesis testing. Okay, so what you have just now is a sample data. Okay, if you discuss the BMI of the UMP student, so what you have here is a sample data. Okay, so now you have two group of data, you have female and male, for example. So you try to conclude for the whole UMP student ni, okay, between male and female, which one is a better one in terms of BMI? So what we do is a hypothesis testing by using the sample data that we have. Okay, and then the conclusion we conclude, oh, man is better than female, for example. Okay, oh, female is better than male, for example. Okay, so the conclusion that we conclude here represent the population. Okay, any question? Okay, what we call the reason why we do the hypothesis testing. Okay, so this is the expected outcome. Okay, so your assignment, we need to conduct a hypothesis testing using Microsoft Excel and p-value approach. Excuse me. Okay, so no need to wait until the end of this chapter to do your assignment part 2. Okay, because assignment part 2, it is just about population mean and difference of the two population mean. Okay, the video already in YouTube for the subtopic hypothesis using Microsoft Excel and also p-value approach. You can start do it from now. Okay, if you already understand the hypothesis for the population mean and also the difference between two population mean, then you can start study about how to do using Microsoft Excel and how to use the p-value approach. Then you can start with your assignment part 2. Okay, no need to wait until we finish that and then you start with the assignment. Okay. Okay, so for the content, we have about 10 subtopic for this chapter. Okay, so 3.1, okay, it is about what we call the theory behind that, the terms that you should know about the hypothesis testing. What is what we call, what is critical value, what is test statistic, what is rejection region, what is acceptance region, what is significant level, all those things you have to know. Okay, so it is discussed in 3.1, the procedure of the hypothesis testing. So in general, we have 5 steps for the hypothesis testing. Okay, so step 1. Okay, step 1, we start with the formulate the hypothesis. Okay, step 2, we calculate the test statistic. Sorry. And then step 3, we have the critical value. Step 4, we make our decision. And then step 5 is a conclusion. So in general, 5 steps. How many methods that we have for the hypothesis testing? Anyone? How many methods? 3 methods. What are them? What are those methods? Anyone?
Traditional,
Traditional?
confidence interval,
What?
Confidence interval,
Confidence interval. Another one?
p-value,
p-value,
P-value method. Okay, so all together we have 3 methods. Okay, the one that we discussed from 3.2 until 3.7 here, it is about traditional method. Okay, when you need to calculate the test statistic, automatically traditional method. Okay, the second method that we have is a confidence interval method. That's why I said chapter 2 and 3, they are related to each other. Okay, when we said hypothesis testing by using confidence interval method, means that confidence interval the whole chapter 2 just now. Okay, so depends what parameter that we have in our hypothesis. Is mu, then confidence interval for the mu. Population between 2 mu, so confidence interval of the 2 population mean. Okay, that's why if you go through okay, after this, when we go to the final, you go through the final question, you can find we have one scenario, we have one question, but after that we have question about chapter 2 and then question about chapter 3. They are related to each other. Okay, because of this one, because we have hypothesis using confidence interval. Okay, and the third one, we have we have hypothesis testing by using p-value approach. Okay, so p-value approach, there's nothing that you have to calculate manual. Okay, when you need to use p-value approach, we will give you the output from Microsoft Excel. Okay, we provide you the output from Microsoft Excel, then you just read from the output which one represent the p-value. Okay, so different method when we do the decision, it will be different value that we compare. Okay. So that's a different lah. Okay. And then the last subtopic here, we have the error. When we discuss confidence interval, you have the estimation error, but for the hypothesis, we have type 1 and type 2 errors. Okay. So statistical hypothesis, okay, the statement about the parameter or parameters about one or more population. So that's why when you formulate your hypothesis, it is about parameter. Notation, it is about population, so notation must be parameter. Okay, so it will be either mu, sigma, sigma square, or pi. We cannot use notation for the sample because statistical hypothesis, it is about population. Okay. Okay, the type of test for the statistical hypothesis, we have two types, two tail and one tail. But for the one tail, it is right tail and left tail. So how do we decide this? Based on the sign of H1. Okay, so H null. Okay, so both H null and H1, both it is about population. So H null is a parameter that do not cover, sorry, the what we call H null here represent the situation that do not covered by H1, and H1 represents situation that do not covered by H null. So for example that we have line number. Okay, if we say that H null cover from 3 below, automatically, okay, H null from 3 below, then automatically H1 3 onward. Okay, they cannot be overlap in any point. Cannot be overlap in any point. That's why here we have shaded circle. This one here just unshaded circle. So the 3 here covered by H null. Okay, and then after that covered by H1. So they cannot be overlap to each other, H null and H1. Okay, and it is about parameter, it is about population. Okay. So how do we define? We have two tail, right tail and left tail. It is based on the sign that we have at H1. Not equal, you will have two tail. Greater than, you will have right tail. And less than, you will have left tail. Okay, so how do we differentiate between H null and H1? Okay. In your question will give you either one, whether H null or H1. When we have H null, you should you can write the H1. When we have H1, okay, you should, okay, you can write the H null. Okay, because it is like I said, statement because of this. H null statement that do not cover by H1, H1 statement that do not cover by H null. When we have either one, you can write the other one. You're supposed to. Okay, you should can write the other one. Okay. So in your question, it gives you either one, whether H null or H1. So how do we know the statement given, it is about H null or H1? Okay, it is based on the sign that we have. Okay, H null, it will be always with equal sign. If you get equal, if you get less and equal, if you get greater and equal from the statement in your question, that H null. Okay, when we have equal sign. Okay, if you have unequal, sorry, you have less than or you have greater than, it will be H1. Okay, that's how we know the statement given in that question, Hashna or Hashman, based on the sign that we get from that question. Okay, what else that you have to know? Any questions so far? Okay. Okay, this is the common phrase that we use for the hypothesis. Okay, you should be well known with this term. Okay. Okay, I will explain this one when we go to the exercise. Okay. So hypothesis testing for the population mean. Okay. So when we set population mean, automatically parameter should be mu in your hypothesis. Okay. So mu note here will be given in your question. The population mean value. Okay. The mu note is a hypothesized mean or population mean or true mean. Okay, it will be given in your question. It is between negative infinity to the infinity. If there is no mean given, then it is 0. Okay, but usually for the single mu, it will be given in your question. Okay, so thus a population mean when population variance is known or unknown. So we still have three formula as a confidence interval. The difference is we calculate for the task. So for the mu here, you will have either Z task or T task. Okay, when you have Z task, automatically critical value is Z alpha. When you have T task, automatically critical value is a T alpha. T distribution. We cannot compare different things. We cannot compare Z task with the T distribution. Okay, it is wrong. Different characteristic. Okay. So how do we choose the formula similar? We need to know what condition that we have in that question. Whether it is sigma known or whether it is unknown. Okay. So as what we discussed in confidence interval, sigma is known means that we do have sigma in that question. Sigma square is unknown. We only have S in that question. Okay. Any questions so far? Okay. We go to the exercise. Okay. I ask you to do number 5 here. Okay. Have you done? Have you done? Okay. What is the variable? What is the variable in this case? Okay, so the first step, similar as a confidence interval, we need to extract the information. Okay, first variable. What variable that we have here? Hypothesis testing variable is very important because it will also influence the sign for your hypothesis. Variable. New rocket accuracy. Okay. What kind of data that we collected here? The mean calculate here, the standard deviation here, based on what? Based on what data? Distance. Distance to the average. Distance to the average. Sorry, distance to average pula. Apa? Miss its target. So distance to the target. Okay, the average here, the standard deviation here will calculate from the rocket miss its target. So distance to target. Okay. Okay, distance to its target. Okay. A rocket meets its target by an average of 0.88 km with a standard deviation of 0.04 km. Okay, a new design rocket is supposed to increase accuracy, and a random sample of the 30 locations were occupied with this new rocket to test it. Okay, what is 0.88 here? Zero 0.88. Let's go. Anyone? Lain? Another answer? It is mu. Okay, so 0.88 is a mu. The 0.04 here? What is that? 0.04? It is sigma. Okay. So 0.88 and 0.04 here is what we call population value. Okay, one of the hint that we can use here, 0.88, 0.04 from, were mentioned before we have the sample here. And then we have a new design rocket. So the rocket here is supposed to be the old rocket, the former rocket. Because now we are testing for the new rocket. So the rocket here supposed to be the old rocket. So anything about something that already happened, it is population. So 0.88, 0.04 here is the population value. Okay, because it is about the old rocket, and also it was mentioned before we have the sample here. Got it? So a new design rocket is supposed to increase accuracy and a random sample of the 30 location. So the 30 here, that's your N. So we have 30 rocket that we test. These 30 rockets miss by distance with a mean of 0.76 and standard deviation of 0.04. What is 0.76 here?
X bar.
X bar. Because it is about this 30 rocket, and 30 is our N. So 0.76 S bar. And then another 0.04 here. S. Okay. Does the new design rocket able to increase the accuracy at 0.1 significant level? What is 0.1% here? Alpha. If alpha is not mentioned, what is your alpha? If there is no alpha in our question, what is our alpha? 0.05. So we use the standard one, which is 5%. Okay, if there is no alpha in your question, do not ask me lah, what is our alpha? Okay, because when there is no alpha in our question, we assume that the standard one, 0.05. Okay, so in this case, we have alpha 0.1%. Okay, so still in percent, we convert, you get 0.01. Okay. Okay. We're done with the information. So the first step to your hypothesis, Okay, does the new design rocket able to increase the accuracy? So we need to answer that. We need to conclude that. So automatically hypothesis testing. Okay, it is not confident interval because it is not mentioned that you have to construct the confident interval. Does the new? So we need to answer that. So automatically you have to construct or you have to form the hypothesis testing. Okay, so the first step is hypothesis. So the hypothesis here is coming from the question here. Does the new design rocket able to increase the accuracy? Usually it will be at the end of your statement, okay, in your question. So what we call the hypothesis is from the purpose of the question. So in this question, the purpose is to check or to know whether the new rocket able to increase the accuracy. So that's your hypothesis. Okay, the purpose of this question, that's your hypothesis. The keyword here, increase accuracy. Okay. So first, what parameter that we have to use for this hypothesis? What parameter? I know that you know it's a mu. Why mu? Why here we have to use mu?
Accuracy.
Accuracy. Okay, if we go back to the chapter 1, okay, other than mu, what we can use to discuss the accuracy from the chapter 1? Still remember? Other than mean, okay, what is another measure that we can use to discuss the accuracy? It is standard deviation. So variability. Okay, but here, why we cannot use variability? Why we have to go to the mean? Okay. In order to know what parameter that we have to use, some question, it will be direct in your question that the parameter is a mu. For example, if we go to exercise. Okay, for example, the number 2 here. Based on the sample, can we start the wood cutting process? So start the wood cutting process. What we need to do? So back to the above statement. Okay, if the mean height of the ruler is not equal to the 100, the process will be stopped immediately. So it is clear that if the mean height of the ruler is not equal to the 100, then the process will start immediately. So it is clear that you have mean as your parameter. Okay. Here. Not really clear here. Okay. For example, and here also, number 4 here. New method to have a smaller mean. Investigate the manufacturer expectation. So he expect that the new method to have a smaller mean. So it is clear that we have mean here, so parameter is a mu. Because in order to investigate this expectation, we need to know about the mean here, what happened to the mean here. So it is clear that parameter is a mu, okay? But in this case, it just increase the accuracy, okay? And we know that probability also we can use to discuss the accuracy, okay? So we need to go to the information that we have in this question, okay? If the parameter is mu, what estimator that we need? If we need to discuss the mu, what estimator that we need? Anyone?
S bar.
S bar. We do have S bar in this case, isn't it? Okay. If we need to discuss the sigma, what estimator that we need? S. Also, we have S here. We have sigma. So we have the population variance as our sigma node. Okay. And we have S as our estimator. Okay. But the value of the sigma and S, they are similar to each other. What does it mean? What does it mean? Sigma and S equal to each other. Sigma, okay, the standard deviation of the old rocket similar to the standard deviation of the new rocket. What does it mean? In terms of the accuracy, it gives effect or not? Is this effect the accuracy or not? Sigma and S equal to each other. No. So there is no significant what we call fraction of variability when we discuss the accuracy in this case. Because sigma and S, they are equal to each other. So there is no use for us to use the variability to discuss the accuracy in this case. Because sigma and S, they are equal to each other. So the accuracy of the rocket here does not give an effect to the variability. So we cannot use variability. So that's why we go to the mean. Automatically here cannot be proportion because the data that we have here is a quantitative data. Okay, if you have qualitative data, then we go to the proportion. But here, quantitative data, it is about distance. Okay, quantitative. Distance to the target. So quantitative data, possible parameter to use, it will be either mu or sigma. Okay, so sigma just now, we have sigma equal to the S. So there is no effect on the variability for the accuracy in this case. It means that to discuss the accuracy here, variability does not give any effect. So that's why we go to the mean. Okay, so the reason similar as when we discuss chapter 1, okay, dulu, week 1, okay. Why we go to variability? Okay, in certain case, if mean equal to each other, then we go to variability. Because when mean 1 equal to the mean 2, means that there is no effect of the mean in that case. So that's why we go to the variability. And here, in this case, variability does not give any effect. So that's why we go to the mu. Any question? Okay. So the keyword is in your question. Okay. Also depends on information that we have here. Okay, to choose what parameter that we need to use for our hypothesis. So now it is a mu. Okay, mu. We do have the population mean here, 0.88 for your right hand side. Okay, right hand side should be mu naught. So mu naught is a population mean or true mean value or the hypothesized mean. So you have this. Now, what? The sign. Increase the accuracy. So increase the accuracy. The sign should be what? The sign should be what? To increase the accuracy. Greater than, okay. how to increase the accuracy on the distance to the target. What happened to the distance to the target if accuracy increase? Betul kan ayat saya tu? What happened to the distance to the target if the accuracy of the rocket increase? Closer, so it should be less than. Increase the accuracy here should be less than because accuracy here. Okay, so that's why I say you have to know what is your variable. Okay, to discuss the accuracy here, to increase the accuracy, what happened to the variable? The distance should be smaller. That's why increase accuracy should be less than, even though you have word increase. Okay, so this is the example of increase does not mean greater than. Okay, it is not whenever you have increase, it will be greater than. No, you have to look at your variable, you have to look at another keyword. So accuracy here in terms of distance, it should be smaller, so less than. Mu naught 0.88. H0 or H1? H0 or H1?
H1.
Again, H0 or H1?
H1
Kenapa H1?
not equal.
Not equal sign because you just have less than. There is no equal sign, so H1. Automatically H0, mu, opposite to less than,
Greater.
ada lagi tak after that?
Greater and equal.
Greater and equal to 0.88. Okay. So these two hypotheses must be cover all the condition, but they cannot be overlap to each other. Okay. So H1 here less than, automatically H1, H0 should be greater and equal. Okay, so in this case, we already cover all the condition, all the situation, but they're not what we call overlap to each other. Where is your claim?
H1.
H1. Okay, so claim what we call which hypothesis that you get from the question, that's where your claim. So in this case, we get H1, so claim is at H1. Okay, that it is not compulsory to state the claim. I repeat, it is not compulsory to state the claim, but it will be easy to write the conclusion letter if you state the claim. Okay, so if you do not write your claim, you still get full mark on hypothesis. Okay, so it's not compulsory. So step 2, we need to choose the test statistic. So we have 3 different formula. Okay, so the first condition, sigma is known or unknown. In this case, known or unknown? Known or unknown? It is known because you have sigma value. So sigma is known, so go to the first formula with the Z test. S bar minus mu naught divide by sigma divide by square root n. So you have S bar, mu naught, and then sigma is a 0.04, and then n is a 30. So we have negative berapa tadi tu? 4317. Okay, so 4 decimal places. Okay, that's step 2. Step 3. What is step 3?
Z table.
Critical value. Okay, step 3, critical. Okay. So, the hypothesis here, the type of hypothesis, kita ada apa? The type of task. Right tail, left tail, or two tail? The type of task. It is
Left.
left tail. So we have less than, then it is left tail. What happened to the alpha? Should we divide by 2 or not?
No need.
No need. So because left tail is a one tail, so no need to divide alpha by 2. Okay. So I suggest you to sketch. So left tail, we have this one. So you will left tail for the Z, it will be negative Z alpha. Okay, so alpha 0.01. So negative Z 0.01, we get 0.001. 31, sorry. 30902. Anyone? .0902. So negative 3.0902. Okay. So for the left tail, the shaded region here, that's your rejection region. The unshaded here, acceptance region. Okay, the point that separate between rejection and acceptance, your critical value, this one. Okay, so if your Z test fall in rejection region, then decision should be reject hash null. If your Z test fall in acceptance region, then decision should be do not reject hash null. We do not write as a accept hash null. Okay, it is do not reject hash null. Okay, so you can plot your Z test. So it is negative 16. So where is a negative 16? Should be in rejection region, should be less than critical value, or should be greater than critical value? The negative 16. Should be less than.
than.
So somewhere here. That's your Z test. So when you sketch this figure, plot. Where is your Z test? Where is your critical value? When you plot, don't forget to label. Okay, this is belong to Z test. This is belong to critical value. Okay. So step 4 is to make your decision. Okay, step 3 is to find the critical value lah. Step 4 is to make your decision. So to make your decision, you can plot. Where is your Z test in this figure? So Z test less than negative Z 0.01, decision. Decision. Reject hash null. Okay, so for the decision, it will be only 2 possible answers. Whether you reject hash null or whether you do not reject hash null. Okay. No, other than that, it will be rejected lah. Okay. Step 5, conclusion. So you can write anything on your conclusion. It is not necessary to follow the standard sentence from your module. You can write anything. Okay. So reject hash null means that we reject the hash null here, isn't it? Betul? Okay. Reject Hashna means that we reject the Hashna. So which one that we support? Hashna or H1?
H1.
H1. So do we support the claim or not?
Yes.
Yes,
Yes.
because claim at H1 and we support the H1. So automatically we support the claim. So to write the conclusion here, the first one, it is compulsory to write the alpha because this conclusion, okay, the conclusion that we made here, it is about the population. So this conclusion only valid for the alpha 0.001. Okay, because if we change the alpha here, the value could be different, decision could be different. Okay, that's why it is compulsory to write the alpha. So at alpha 0.001, so we support the claim. Okay, so means that if we answer the question at alpha 0.01, the new design rocket able to increase the accuracy. Or if we talk about the claim, at alpha 0.01, there is any question? Okay. Ataupun you can write there is not enough evidence to reject the claim that the new rocket increased accuracy. Or you can write at alpha 0.01, the new rocket increased accuracy. Also accepted. So it's up to you how you are going to write your conclusion. As long as you write the one that you supposed to support lah, based on your decision. Any question? Any question?
Madam,
Dekat mana ni?
How if the S was not equal to sigma, which parameters would be considered mean? Both also okay. Because accuracy it is about probability and mean. You can, but when we talk about probability, when we talk about accuracy, usually we go to the probability. Okay, so you can consider probability first. Okay, any more question? What? Sorry. Hujung cakap kan. Or actually, when you have to use sigma, usually it will be some keyword in your question. For example, based on durability, like that lah. Okay. But actually, both are correct lah. In this case, you can use mu or sigma if sigma is not equal to the S. Okay, any more question?
So if both sigma and S are equal, and then so just choose based on the question lah.
Yes. So maksudnya if the S and sigma is not equal to each other, we can also use variance here as a parameter. So the rest, I mean the test statistic will be different lah if we use sigma as our parameter. Any more question? So again, next week, it will be confirmed that Wednesday there is no class. Okay, because I got something to do. And then on Monday, I will inform later whether we have class or not on Monday. But if we have class, I'm going to discuss about your test lah. Or maybe you can ask me any question regarding the test, or maybe you can do the past semester questions, then we can discuss. Okay, I will inform later about the class next week. Oh, I still do not upload the what we call the last week virtual class. I will upload maybe today or tomorrow lah. Okay, tak sempat. I will do it today, insyaAllah. Any more question? It's 2 p.m. already. So if this is our last class before the task, good luck lah for the task. Okay, you can always ask me, you can always text me if you have any question regarding the task. So that's all for today. See you during the task or next week, insyaAllah. Thank you, class.
Thank you, madam.
Okay.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, Doctor.
Okay.
Doktor ada attendance tak?
Alamak, lupa. Nanti saya buat.
Okay.
Nanti saya share.
Okay, Doktor.